So good morning students. In this lecture we will see the various biasing technique of diode. So in this one, reverse bias and forward bias we will see. Okay. So in the diode, if we are seeing, we are adding p and n type metal together, and whatever the forming of that is called as diode. The junction point is called as depletion region in this one. Okay. So if you are connecting my n type material to the p type positive terminal of the battery and p type to the negative terminal of the battery, then it is called as reverse bias. And whatever the depletion region at the start, this will get widened up. Okay, widen one, broader one. Okay, why we are getting, because this negative terminal and these holes, these are the positively charged particles, they are get attracted, so this will get this side, and in the reverse bias the electron will get attracted toward the positive terminal. Okay, they will attract, so this gap will be broader like this one. In this case, if you are connecting p type to the positive, means same p and n negative n type. If you are connecting this one, so what will happen, this positive will repel this electron, the holes, and the electron will again repel, this negative terminal will repel this electron, and they are combining one. Okay, they are this conducting over here and they are conducting over here. Okay, we'll see in detail. No bias condition means I have not applied anything. So what will happen, you know that this is a p type metal. Okay, this is a p type, this side left side is p type metal. So if I'm connecting, I have connected to nothing to this in the p type. So holes, if this is a p type, so holes are the majority and electron are some minority. And in the n type, we know that electrons are the majority and holes are the minority. So what will happen, some minority charge carriers are also there, that is nothing but, if 1000 electrons are there in n type, so some 10 holes also there. And in the p type material, if 1000 holes are there, some kind of 10 electrons are there, so they will get attracted over here and they will form a junction over here in from p, that is n type material, that is the electron that has a negative minority charge carrier, and from n type the holes will get attracted. Okay, so I'm watching your comments. So what you have to do, you have to give me the answer in the chat box, that what are the pentavalent impurities. Name, just mention the one impurity pentavalent, and mention the n type impurity, the trivalent impurity, in the chat box. A single impurity is sufficient for me. I am watching your comment. I will watch for 5 to 10 seconds. Okay, good, at least try. Okay, yeah, good. So p type is nothing but what, pentavalent. So pentavalent impurities are antimony, arsenic, and phosphorus. And n type, that is trivalent, is nothing but boron, indium, gallium. Okay, so we have connected this thing. So what will happen, due to this, no current will flow because this junction is open. So id is equal to 0 milliampere. So this will like this one. So operating condition second number, a reverse bias. A reverse bias, what we will do, we are connecting p type to the negative terminal and n type to the positive terminal. So this depletion region will wide up. Okay, this is the symbol of diode. This is origin strip for p type connected, this for n type. Okay, so what will happen in this case, due to this depletion region will wide up, and the current caused to flow is due to the minority charge carrier. We know that current wherever the electron is flowing, the opposite direction current is flowing. Okay, and current is normally flowing from positive terminal to negative terminal. Okay, keep in mind, current is always flow from positive terminal to the negative terminal, and electrons always flow from opposite of that. So electron will flow like this one, from negative to positive electron will flow, now from p-type material, the electron will get injected into the n-type material, and n-type they are get attracted toward this positive terminal, and the current conduction will start. Okay, here the current conduction is very very less, so that is nothing but the minority carrier flow. Second is nothing but the forward bias. Okay, forward bias. So we are connecting p-type to the p-type to the positive and n-type to the negative. Then what will happen in this case? So electron will get attracted to the positive terminal. So the overall current is id is equal to I majority minus I minority, because I majority flowing from positive terminal to negative terminal simultaneously. uh, Reverse bias current, sorry, the current due to the minority charge carrier is also flow. Okay, current due to the minority charge carrier is also flow. So the overall current is nothing but the id majority minus my minority, that is nothing but the reverse current itself. Okay, so actually graph this. So the diode current is given by is, that is nothing but the reverse saturation current, e raised to vd, that is the diode voltage itself, where at what voltage the diode will conduct, divided by neta vt minus 1, where vt is equal to kt by q. Vt is nothing but the thermal voltage we are saying. So k is nothing but my Boltzmann constant, 1.38 into 10 raised to minus 23. Then T is temperature in Kelvin, and Q is in charge on electron, that is nothing but the 1.6 into 10 raised to minus 19 coulomb. Okay, so this graph, what it will show, this is nothing but the dotted line, and this is nothing but the actual commercial curve. So whatever diode we are using, so normally what will happen, if horizontal axis, if you are increasing the voltage, sorry, increasing the voltage, the current will not flow. But what will happen if we are increasing the currents at some voltage, that is the 0.3, for this is for the dotted line indicate for 37 is nothing but for germanium, and this is 0.67 is nothing but for uh, silicon. Okay, so what happened in this case, we know that the bands are there, conduction band and valence band. Okay, so electron are in the valence band. If we are putting that into conduction band, then and then current will cause to flow. So what will happen, if you are giving the voltage greater than 0.37 for the germanium, if you are giving voltage greater than 0.67 to the silicon, then and then current will cause to flow, then and then the electron will shift from conduction band to the valence band. Okay, so this curve will indicate that current will cause to flow, and the reverse saturation current is flowing like this one. Okay, the diode current equation is nothing but id, we'll discuss in detail this one. Id is equal to is in bracket e raised to vd minus neta vt minus 1, where vt is equal to kt by q. So we know that k is nothing but the Boltzmann constant, that is nothing 1.38 into 10 raised to minus 23. The temperature in Kelvin, so normal temperature plus 273 we have to add, that is nothing but temperature in Celsius plus 273 we have to add. Q is nothing but the magnitude of electron charge, that is nothing but 1.6 into 10 raised to minus 19 coulomb, and Vt is nothing but called thermal voltage. Is nothing but reverse saturation current. Vd is nothing but the whatever the voltage we are applying, that is nothing 0.67 whatever this, and neta is nothing but the ideality factor. Normally its range is 1. Okay, so this is all about today's lecture, so we'll stop over here. If you are having any doubts, so please mention your doubt in the comment box, I will answer your doubts. Okay, so thank you very much for attending. Thank you.